In this video, we'll be looking at addition for second grade. The TEKS are 2.4b, 2.4c, 2.4d, and 2.7c. The addition TEKS will be broken up into 3 videos. The first video, which is the one we're doing now, is going to be on addition strategies. The second video will be involving solving addition word problems, and then there's a third video that just goes over QtPack in general. So for this video, we'll be looking only at TEK 2.4b. In TEK 2.4b, the students will be adding up to 4 two-digit numbers. So when we look at some background about these TEKs, students are going to be solving these addition problems using mental strategies, which they're going to get a whole lot of practice on in their number talks. They're also going to be solving using algorithms. Keep in mind that this does not mean the standard algorithm. This means that there is a step-by-step method the students can walk you through what they're doing in order to solve. The standard algorithm does not need to be mastered until 4th grade, so we're going to do a lot of conceptual understanding about what addition is, how place value is involved in that. We want students to be able to practice using concrete manipulatives, concrete materials, moving on to the pictorial, and finally to the abstract. So a couple of concrete materials that you could be using some manipulatives. One, you could use Unifix or the linking cubes, Unifix cubes, in order to help the students if they need to break down a 10 in order to do their regrouping. So the Unifix cubes might be really helpful. This is what they were working with in 1st grade with their addition that they were doing. You also can use the base 10 blocks, and this is what we'll be modeling in the video today. So those are just 2 different concrete materials that you could use. When we're introducing or working with addition problems, we want to be able to set those problems in stories or scenarios. So as we're doing our modeling, we're doing some whole group activities. It gives some context to the numbers that you're using. As students are practicing at their table or doing a game or an activity with a partner, they can absolutely just have random number generators helping them produce problems in order to be solved. But as we're modeling or we're instructing, it's really good practice to put those numbers in some type of scenario. Students will be learning multiple ways to solve an addition problem. We're going to be working on that conceptual understanding, so we're going to kind of take a progression and we're going to get the kids all the way through using manipulatives, moving to pictures, and then looking at a front-end addition, partial sums using place value, and then finally getting into that standard algorithm. That's the most efficient method of solving, at least on paper. Sometimes in our head we can do it a little bit faster. So we're going to encourage the students to solve a problem in 2 ways. That's going to get them to practice one more strategy. We don't want to require kids to solve in a certain way. We want them to explore and find the way that works best for them. But in order to help them practice, just a good idea to get them to solve a problem in 2 ways. When we start working with addition problems and students are going to start practicing these 2-digit addition, we want to start out with the concrete materials. So we would have the students build the number 35 using their base 10 blocks, and we're going to add the 46 to that. So the students can then add their 46 blocks here. Students are going to be regrouping on some problems and not regrouping on others, so we want to give them as much opportunity to practice with what's happening with those manipulatives, what's happening with the ones pieces or the tens pieces as we move on into adding hundreds. So as students start to compile this together, we're going to talk to them about we can't have any more than 10 in any one particular place. It may even be a good idea to put these in a place value chart. So if you had a place value chart that might look like 1s and 10s, something like that might be helpful for them to build their numbers in. So when they start building their numbers, they'll find out that I can take these 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I can trade this out From here, the students can then count, and they can see that they have 10, 20, 30, 40, 50, 60, 70, 80, and then 1 1. So if I have 80 here and 1 here, this means I have 8 10s and 1 1, and I can see that my total is 81 for this problem. We can take this same idea and move it on to the pictorial. So as the students are working with their 35 and 46, we can have them do a pictorial representation of what's happening. So we would want them to draw using models for their base 10 blocks. There's our 35, and 46. And here's where we want the students to go ahead and actually circle those 10 so that they know that in that 10, in the ones place, I can't have more than 10. So I have 5, 6, 7, 8, 9, 10. I can circle these because that's this combining of these 10 here. We can model by drawing another 10 here, trading and taking these away. And then I can see, again, I have 1, 2, 3, 4, 5, 6, 7, 8, or a value of 80, and 1, 1. And again, it would be 81. So that's doing the concrete with the pictorial. Students can also just do the pictorial. We can take away this concrete piece, and the students can just draw the pictures as well. Okay? So another strategy that the students can use in order to solve this exact same problem is to use an open number line. The manipulatives can also help with the open number line depending on how the students are doing their jumping. If we start out very structured, the students could jump by 10s and 1s, and these base 10 blocks can be very helpful with that. But the students don't have to jump by just 10s and 1s. They can do their own variations of jumping, and we want them to be flexible in their thinking in that way. So I'm going to model by doing jumps of 10s and 1s, and we're going to hope that it fits. If I have 35 plus 46, we're going to, we can write down either number to start with. I'm going to write down my highest number so I don't have to do as much jumping. We're going to make sure that we model that both ways so the kids understand that. We can add the 35, and so we can place base 10 blocks like this, and we'll get another mat so we can continue to draw on here to model the jumps that we need to make with our 46. So here's a 10, so 46 plus 10 would be 56, plus another 10 would be 66, plus another 10, 66 would be 76, and then we're going to add 1, 2, 3, 4, 5. And so then we can make the jumps here, 2, 3, 4, 5, 76, 77, 78, 79, 80, and finally 81. So the number line, or using the open number line, we can set it very structured so that the students have a chance to use the manipulative. Students could also, using the open number line, if we're adding 46, and maybe they can make that jump of 30 very quickly on their own, and so they can go, oh, well, if I add plus 30, this is going to be 76, and now I just have to add that 5. And this is where they can work on decomposing that number to make friendly numbers. And they might see this as plus 4, and then a plus 1. And that's where the 5 comes in. 4 plus 1 is 5. So this would make it 80 and 81. And the choice of 4 would be that I'm just getting to a friendly number. I'm getting to a 5 or a 10. And then I can move on from there. Either method is going to get me to 81, One just allows a little bit more flexibility with the students, but the open number line is a great strategy for students to use in addition. So students can also, from the idea of the open number line, we also want to show the students more of a place value based addition system that's going to help them lead right into that standard algorithm. So if I'm adding the numbers 35 plus 46, and I'm just going to rewrite so we have a little bit more space, 35 plus 46. We can take this problem and we can decompose the numbers into sets of tens and ones, very similar to what we have with our base 10 block. So we could model that for the students, that what we're doing is we're adding these numbers. We're just going to show this addition using the decomposed into tens and ones. So this would be 30 plus 5 and 40 plus 6. Students can start either on the left or the right. It doesn't matter. We don't have to have them start in the ones and then move to the tens. So I can see that this is 70 plus 11. So when I add those 46, we can model with the manipulatives. We can have the students see that and 35 and 46. So now I can see these 7, 10, 20, 30, 40, 50, 60, 70, and I can see these 11 ones that I have here. We can break this down even further using tens and ones to help the students see that this would be 80. Sorry, that this would be 81. Okay. Students can also take a much shorter method. If they see this, they could add their tens and ones just going straight down, and they could add their tens and see 11, or their ones and see 11. They could add their tens and see 70 and do their addition this way as well. We just want the students to be flexible in their thinking. So this is our front end addition. This will be more of a partial sums type product. The last strategy that we want to look at is our standard algorithm. We want to go back when we start talking about standard algorithm, take the students back to their base 10 blocks with their 35 and their 46. We can take them back to their pictorial 35 and their 46. And we can go ahead and model what's happening and show that regrouping actually here on this problem. So if we have the students start in their ones, we're going to add the 5 plus the 6 together, and I got 11. We know that we cannot keep this 11 as one separate piece. So we need to make sure, that's where my extra 10 went, this is 46. We need to have the students go ahead and do their regrouping, and we're going to trade out our ones, and we're going to model that here as well of what we have going on. And we're going to show them that we can place the 1 under the ones digit, and this regrouping is going to come up here to the top. So we can even model it by putting it up at the top so they can see that we're going to add this long list together, or this long column of numbers together. So 1 plus 3 is 4, plus 4 more is 8. And again, we get 81. We still want to, with the standard algorithm, take the students from the concrete, the pictorial, to the abstract, start taking away the concrete materials, start taking away the pictorial model, and then to where the students can just practice just this abstractly. Remember that we can't require the students to do one particular way, but we want to expose them to everything. Allow them choice and flexibility. If you have any questions on addition, look at your instructional talk page, or you can contact us.